Hello and welcome back to App for You. In this particular video, we are up with a new problem, coin change, and this problem is particularly from dynamic programming. So in the series of dynamic programming, we have already started the series of dynamic programming, and we have already solved one problem that was about minimum coins, right? So if you remember the minimum coins problem, that is the problem of minimum coins is very much similar to this particular problem of coin change. And well, you can say that there are two versions of the same problem, coin change. So minimum coins problem we have already discussed, and also please note that the minimum coins problem is the prerequisite of this video. So if you haven't watched my video on minimum coins, I'll put the description the link of that particular video in the description. Please watch that first. It is a video of 50 minutes and discuss the entire concept in detail. Then you can basically understand the coin change problem. So the only difference between these two problems is, they are 99% similar, right? Only 1 and 2 line changes in the code, and the rest things remain the same. Anyway, so let us understand the coin change problem. So coin change problem says that you are given with a value of n, and value of n basically indicates that a customer basically wants n rupees. Okay, suppose you want 4 rupee, and there are 3 denominations available. The denomination are 1 rupee coin, 2 rupee coin, 3 rupee coin. Now as per the coin change problem, they have said that in how many ways you can get rupees 4 using these denominations. So there are actually 4 ways in which you can get rupee 4. What is the first way? Taking 4 1 rupee coins, 1 1 1 1, or 2 1 rupee coin plus 1 2 rupee coin, or 2 2 rupee coins, or 1 rupee coin plus 1 3 rupee coin. So you can see there are 4 different ways by which you can get a sum of rupees 4 using the denominations 1, 2 and 3, right? So this is what we have to basically do in the coin change problem. Had it been the minimum coins problem, okay, then the question would be, what is the minimum number of coins required to basically get the amount 4? So you can see, once you have all the possible ways, you can see that the minimum coins that is required is basically nothing but 2, because you can see these 2 ways require 2 coins to get a sum of 4. This particular way requires 3 coins, and this particular way requires 4 coins. So the minimum coins required to get rupees 4 was 2. That is the first version of the problem, wherein we have to find the minimum coins. But as I said, this problem is of coin change, wherein we have to focus on the different possible ways of getting the amount 4, right? And hence the answer to this question is 4, because first way, second way, third way, 4 way. So I hope you have already watched my video on minimum coins. Now let us quickly jump into the discussion about the coin change problem. So what I'm going to do is, I'm going to discuss this problem in detail and code accordingly. So let us first create the array that is provided. What is the array that is provided? The array that is provided is nothing but S, right? The array S, or it is an array of denominations. What is the value stored here? Obviously 1, because I have 1 rupee coin, I have 2 rupee coin, as well as I have 3 rupee coin. Now talking about the index, what is the index of this? 0, 1, 2. Please pay attention to these details. Now as I have created a 2-dimensional table in the minimum coin problem. Why? Because the dynamic programming is basically will be exploiting that particular table to reduce the complexity of the problem, right? Because we can see that there was the concept of overlapping subproblem. So overlapping subproblem concept exists here also. That thing I have already discussed in my video on minimum coin exchange. So just understand that I will be using a table for exploiting the property of dynamic programming and reducing the complexity of the code. So as in the previous problem on minimum coins, what we used to do, if my amount is equal to 4, it is given, n is equal to 4 means what amount do you want? I want rupee 4. So you will be creating a table with 4 plus 1, which is equal to 5 columns. That is why I will be creating 5 columns here. So this is my first column, second column, third column, fourth column and fifth column. What the point? Next is, what are the total denominations that exist? So there are basically 3 denominations present in this table. That is, the size of m is basically nothing but 3. m equal to 3 indicates how many elements are there in the array S. So basically 3 elements are there in the array. So the number of rows in the table will be equal to basically m plus 1, which is nothing but 3 plus 1 equal to 4. So how many rows will be there in this table? There will be 4 rows. First row, second row, third and fourth row. Got the point? So let me number it. So for that I have to erase this. So as I said, the columns indicate the amount, right? So columns indicate the amount. So the very first amount that I'm going to declare here is 0, 1, 2, 3, and you need a 4 rupee. So I am going to start from the base condition and I'm going to reach to 4, right? Because I am interested in finding how many ways are there to get rupees 4. But before finding the ways of getting rupees 4, you should basically try to solve its sub problems. So sub problems are how many ways are there to get rupees 3, how many ways are there to get rupees 2, how many ways are there to get rupee 1, how many ways are there to get rupees 0. So you will basically start with this problem: how many ways to get rupees 0, how many ways to get rupees 1, how many ways to get rupees 2, how many ways to get rupees 3, and so on, and then you will reach to how many ways are there to get rupees 4. So you can see we are basically solving the sub problems to get the solution to the original problem, right? By combining their solutions of the individual sub problems. Let us see how it works. So this we have already understood that this indicates nothing but the amount. And remember, the total number of denominations that were available are 3. So I am basically creating a row of 3 plus 1, which is 4 rows, right? Starting with 0, 1, 2, and 3. Remember, these are nothing but index. Okay, so whenever I say that I am at this row, means index 3, then remember I am actually talking about 3 minus 1, that is equal to 2, index 2 of the array S. Getting the point? So let me do one thing. Let me use variables. So I will be using an I variable which will keep track of the row number. I will be using a j variable to keep track of the column number. Now remember, I minus 1 index in S. Okay, so whenever I for each value of I, so for each I, refer I minus 1 index in S. So whenever I say this I 1, so remember I am talking actually about 1 minus 1, which is 0, index of array S, which means the element in this index is nothing but 1. If I say index 2, I is 2, which means I is equal to 2, means I am talking about index 2 minus 1, which is nothing but 1 of this array S. Similarly, I equal to 3 indicates I am actually referring to index 3 minus 1 equal to 2 of this array S, right? Now I will be explaining that in detail in the further, but let us now start solving the problem. So as you can see, I have basically created an array. So it's time to declare the array first parallelly in the code. So I'll be declaring integer dp, and number of rows were basically m plus 1, number of columns is nothing but n plus 1. Done. Fine. Remember, what is the objective? Objective of this particular problem is to find total ways to get a sum of rupees n. This is the objective of this problem, right? So I hope you are not forgetting this. We are going to find total number of ways to get a sum of rupees n. So since we are going to use dynamic programming, obviously we are going to use recursion. What will be the base condition? So the base condition is the solution to the sub problems. What is the solution? Basically, j, as I said you, if you refer to this particular row, this particular column, j equal to 0, and what is j? J is nothing but amount. So amount equal to 0, and right now I am in this row. Here 0 indicates no denomination. Suppose you don't have any denomination. Okay, so when I am saying 0, then I am actually saying that you don't have any denomination with you. Okay, there is no denominations that actually exist, and I am saying you there is no denomination that actually exists, and I want a rupee 0, and I want nothing. So this basically means you have nothing. Just understand, this means you have nothing. 0 means you have nothing, and this 0 means I want something. So basically I want something, I want nothing from you. 0 means nothing, so I want nothing from you, and you also have nothing. How many ways can that be satisfied? One way. I want nothing, you have nothing, so do nothing. That is why one way. Done. Next, I want 1 rupee, you have nothing, can you fulfill my request? No, never. Because I want 1 rupee but you don't have anything, right? Because I right now is pointing to 0. 0 indicates no denomination exists. So 0 way to fulfill. I want 2 rupee, you have nothing, can you give me? 0 way. I want 3 rupee, you have nothing, can you give me? 0 way. I want 4 rupee but you have no denomination, can you give me anything? No. So there are 0 ways to fulfill my demand. Got the point? This way I will say that whenever j is equal to okay, before that let us fulfill this condition also. Now focus on this column. I want nothing and you have nothing, so how many ways can you fulfill my demand? One way, by doing nothing. I want nothing but you have. Now see, when I say that I is pointing to this row, when I will say that I is pointing to this row, then it means that I am allowed. Remember, this is very important line. When I say that my I pointer is actually pointing to this row, what is the value here? 1. And 1 means point to 1 minus 1 index of this row, this array, which is nothing but this index. So whenever I say that I is pointing to this particular value, just note that point to I minus 1 index of that array, and all the elements from starting till that position can be used to get a specific amount. Getting the point? Just note this. So right now I say I is pointing to 1. So when I is pointing to 1, it indicates I am referring to this index 0 here, which means I can use all the denominations from starting till this index, which is nothing but 1. So now I am asking myself, in how many ways can you actually give me nothing, given that you have 1 rupee denomination? Definitely one way, by not giving me anything, because I don't want anything and you have something, but I am saying don't give me anything, so definitely you will not give me anything. That is also one way of satisfying my request. So here again I am requesting don't give me anything, and you are pointing to basically which index? This index. You are pointing to this index indicates you can use all the denominations from starting till this point. So given that you have these denominations with you, but as I said I want nothing, so if I want nothing, what will you do? You will not give me anything. So basically one way to fulfill my request. Same for this also. Done. So I will basically fulfill this particular base condition. So I will fulfill this particular base condition, and what will I write here? So this condition, first of all, I write if basically j is equal to 0. If I am saying that if j is equal to 0, so what we are going to do is basically, if j is equal to 0, I am going to say dp of I of j is equal to what? Remember, if j is equal to 0, like in this particular case, when I am pointing to this column, all the values here, j equal to 0 means I want nothing. So basically value 1 will be there for all these particular denominations, right? So dp of ij is equal to 1. Initialize it. So I have initialized it. Else if dp of, so we have successfully filled this particular column, right? Now the base condition will be for this row. That is, if I have no denomination with me, which means I don't have any money with me, and you are asking me for no money. So one way for that we have already filled. But if I have no money with me and you are asking me 1 rupee, can I give you anything? Definitely no. So I cannot fulfill your request. I have no money with me but you want 2 rupee. Can I give you? No. So 0 way of fulfilling the request. I have no money but you want 3 rupee. So how many ways can I give you 3 rupee if I don't have any money? 0 way. I can never give you money, right? Same for here also. So for this condition I am going to say if my I is equal to 0, else if I is equal to 0, it indicates that you should fill dp of ij as 0, right? Because that indicates that there is no possible way in which you can give me money, right? Now another condition is basically, before going to that condition, let me explain you some more thing. Now since we have already filled the cells with the base condition, let me start from this particular cell. Now when I am at this particular cell, what does it mean? It means that let me show you one thing. If I am at this particular cell, which means I am in this row, and when I am in this row, please note that when I'm in this row, it indicates that maximum denomination that you can use is actually nothing but the value of this is 1. So 1 minus 1 is 0. 0 index. 0 index is nothing but 1. This, which means the maximum denomination that you have actually is 1. So suppose that the maximum denomination you have is 1 in your pocket. 1 rupee coins, maximum, many 1 rupee coins you have in your pocket, and I'm asking you that in how many ways can you give me 1 rupee? Okay, so please keep in mind one thing. So I am saying you that okay, your eye pointer is now pointing to this row. When eye is pointing to this row, it indicates you should basically assume that 1 minus 1 is 0, means go to this index and see what value is there, 1, which means from starting to that index, whatever denominations are there you can use. So you can see starting is this and 0 index is also this. So only one denomination I can use, that is 1. So you want 1 rupee, and so someone wants 1 rupee, and you have 1 rupee coins in your pocket, many 1 rupee coins. Okay, so in how many ways can I give you 1 rupee? So one way will be, okay, one way will be that okay, I will give you 1 rupee. Just pick up a coin from your pocket and give him. How many money does he want now? 0 rupees. Right? So this is one way. Or the other way is I will not use the 1 rupee denomination. Although you have many 1 rupee denomination, but you are not going to use any 1 rupee denomination, and you are going to see if there is an alternative way to give him 1 rupee. So if I don't use 1 rupee denomination, that means I should actually look into the previous row with no denomination with me. So with no denomination with me, can I give him 1 rupee? In how many ways? 0 ways. So a sum of 0, okay, plus, okay, you see, this condition will be basically, I will say dp of ij will be equal to dp of, suppose I don't use 1 rupee coin, then I should move into the previous row, I minus 1j, plus, otherwise if I'm using the 1 rupee coin, then I should remain in the same row. But since I have used the 1 rupee coin, so the initial amount minus the value of the current denomination, the maximum denomination that is being used. Isn't it? This was the mathematical relation that we have to use here. Are you getting the point? So if I say dp of 1 comma 1, what will it be equal to? So it will be equal to dp of 1 minus 1 means 0, j is again 1, plus dp of I is nothing but 1, and j is nothing but I want 1 rupee, and s of I minus 1, so I is basically this, I minus 1 is 0, s of 0 is nothing but 1. So what is the value of that? 1. So 1, so basically j means, j is what? J is 1 and you took 1 rupee. What is the value of this? 0. So what is the value of dp of 0 1? dp of 0 1 is nothing but 0 and 1 here, 0, plus dp of 1 0, dp of 1 and first row 0th column 1. What is the value? 1. You got 1, which means dp of 1 1 should be filled with a value 1. So dp 1 1 I'll fill with the value 1. How did I get 1? Basically I used two combinations. The first combination was, I will assume that I have not used the denomination which I is pointing to. Whichever denomination this is pointing to, basically I minus 1 0, this denomination, I will assume that I will not be using this denomination, and I will see how many ways are there getting rupees 1 without using this denomination, plus I will use this denomination. So if I use this denomination, basically whatever amount I want, I have reduced one amount from that. So how much value did you reduce from that? j I minus 1. Right, so this will become more clear when I am going to solve the further cells, so don't worry right now. Okay, so I filled it with 1. So likewise, what will happen? So I want 2 rupee, and I have maximum which denomination with me? So maximum denomination is pointed by the index 1 minus 1, that is 0, 1. So how many ways can you basically give me 2 rupee, given that you can use a maximum denomination of 1? Okay, so how many ways are there? So you see what we are going to do. So let me erase this. There are actually 2 ways, right? 2 ways. How? First of all, well, I know the formula is nothing but dp of ij is equal to nothing but dp of I minus 1 j plus dp of I comma j minus s of I minus 1. I hope you are getting this point. So this indicates ignore denomination. Okay, ignore this denomination, and this indicates include the denomination. So right now I am pointing to this row. I'm in this row only because remember, every row, every column will be traversed. So I have filled this element. Now I am talking about this cell. So this cell, basically I am interested in finding dp of what? Row 1 column 2. And as per our formula, what is it? The first case is when I will ignore this denomination. So basically, what is the maximum denomination if I were pointing in this row? What is the maximum denomination you can use? 1 rupee coin. Suppose you are not interested in using this 1 rupee coin. So that is why I will be saying dp of I minus 1. So I is 1, 1 minus 1 is 0. So basically, which denominations you are going to use now? All the denominations above this, that is 0, no denomination. Bracket, you write j. What is the value of j? 2 plus dp of I is nothing but 1. And what is this case? This case is when you are including the denomination. So previously I said I am not interested in using 1 rupee, but now you are saying okay, I will be using this denomination which is allowed. So I will be using 1 rupee. So the moment you use 1 rupee, remember you want 2 rupee coin. How much do you want? You want 2 rupee, but I am giving you just 1 rupee coin. So I am including 1 rupee coin. That is why from 2 rupee I will be subtracting what? S of I minus 1. So S of this I is 1. So 1 minus 1 is 0, 1. Since you have included 1 denomination, that is why it comes 2. That is the amount that you want minus the denomination that you picked up. So what will be the value? dp of 0 2 will be what? So 0 2 is nothing but 0 plus dp of 1 1. So dp of 1 is nothing but 1. What will be the answer? 1. You will fill this cell with value 1. So I hope you are getting the point. How is this actually being computed, right? So same case for here also. So in how many ways can you give me amount rupees 3, given that maximum denominations there are 1? So for this also, if you just go by this formula, wherein you will be assuming that okay, maximum denomination I can use is 1, which means this denomination. I have two possibility. Either I will include it. So whenever I will include it, what will happen? dp of what do I want? I want 1 comma 3. So the formula says dp of 0 and 3 plus dp of 1, and 3 minus 1 is what? 2, isn't it? Because s of I minus 1 is nothing but 1 right now. So I am assuming I have picked 1 rupee coin. Okay, so you want 3 rupees, but I gave you 1 rupee. So how much money is left? 2 rupees left. So that is why now you already have a solution to this. In how many ways can you get a sum of rupee 2 given you can basically use the maximum denomination pointed by this index. So 1 minus 1 nothing but 0. So means this row, this column. So you just now we have already solved this particular value, isn't it? We just now solved this particular value. So see, the overlapping sub problems concept comes into existence. We have already solved the problem for this particular statement, that how many ways can I get rupees 2 using, given that I can use the maximum denomination of this. So I got the answer 1. Previously I have calculated this. So right now you can just refer the table and take the value. What is the value of this? Value of this is basically 1. Value of 03 is how much? 03 is nothing but 0. So again you get how much? 1. So likewise for this entire row you will get 1 if you compute, right? Now let us make things more interesting. Let us make the things more interesting. Now I will basically increment to which row? The next row. So I is now pointing to 2. Now if I is pointing to 2, okay, now if I is pointing to 2, it indicates that you can actually use all the denominations from the starting till this index minus 1. So 2 minus 1 is how much? 1, pointing to this 2. So it indicates that whenever you are in this row, the problem says that now you can use all the denominations from the starting to this end. Okay, but right now focus on the highest. From starting denomination to this denomination. So you have infinite 1 rupee coin with you and infinite 2 rupee coin with you. Okay, so I am pointing to this row. It indicates you can now use all the denominations from the starting till 2 minus 1, that is this index. So I can use this denomination, I can use these denominations. And now I am asking you, given that you can use a 2 rupee denomination also, so how many ways can you give me 1 rupee? So how will you get the answer? So first of all, this is an exception. Why? You see, whenever the maximum, now I want 1 rupee, whenever the maximum allowable denomination pointed by this value is 2 minus 1 is 0, 2 minus 1 is 1, pointing to this index. So maximum denomination here is 2. Can you give me 1 rupee using a 2 rupee coin? I want 1 rupee, but you have a 2 rupee coin. Can you give me? Definitely not. So that case, what should happen? There is zero way to give it, isn't it? So for that particular, so not zero way to give it using 2 rupee coin. But remember, what did I say? If I is pointing to this row, just take it easy. Okay. If I is pointing to this row, it indicates that you should actually refer to which index? 2 minus 1, which is 1. So refer to this 1 index. So I will be referring to the index 1. So let me just erase these things. This is 1, this is 2. So when I is pointing to this value, this row, whose value is 2, so I is equal to 2 indicates you should refer to S of I minus 1, which is S of 2 minus 1 equal to S of 1. So refer to this, which means you can now use 2 rupee denomination, because this value is nothing but 2. This index is pointing to this 2. So now if I ask you, in how many way can you give me 1 rupee using a 2 rupee coin? Can you give me? No. What will you do then? You will basically, whenever I come across a denomination, whenever I find that the denomination is actually greater than the value I want, I will not be able to give it using 2, but I know that I am allowed to use all denominations from starting till 2. So if I cannot give it using 2, then ignore it. Just see how many ways you can give it using 1. Getting the point? So right now I am here. This is 2. It means point to 2 minus 1, which is this index, which means you are now able to use all the denominations from the starting till this. Okay, but I can use all the denominations from the starting till this, but I'll start with the maximum denomination first. So maximum denomination is 2. Can you give me 1 rupee using 2 rupee coin? No. Then what will you do? You will refer to dp of I minus 1 j. So refer to, I want what? I want 2, the value I want is dp of 2 comma 1. So value I want is basically dp of 2 of 1. I found out that the maximum denomination pointed by this is nothing but 2, which is greater than the value I want. In that case, they have asked me to go for dp I minus 1 j, which means dp of I is 2, so 2 minus 1 is nothing but 1, j is nothing but 1. dp of 1 1, which means just the previous row. Just go to the previous row, because you cannot use the maximum denomination. So just see, ignore this denomination and see whether excluding this, can you get this particular amount? Yes, dp of 1 1 is nothing but 1. So there is one way in which I can get an amount of rupees 1, given that I have all the denominations from this to this. Okay, given that you have all the denominations from 1 as well as 2, but since you cannot use 2 to get 1, so you will definitely use 1 to get 1. So there is one way to get it. Similarly, if I ask you how many ways are there to get 2 rupees from given that you have a 2 rupee denomination, so how many ways are there? So what will you do? Basically 2 things you will do, right? What are the 2 things? So right now there is no issue of having a higher denomination, because obviously you can get 2 rupee using 2 rupee. So but my question right now is dp of 2 2. Everything is fine. How will you calculate? Again you will do this thing. You will consider one case where you are not considering a 2 rupee denomination. You are not interested in, although you have it, but you are not interested in using a 2 rupee denomination. So what will I do? I will ignore the 2 rupee denomination. That is why tp of 2 minus 1, you are ignoring it. I am just putting in the value in the formula, and j value is again 2 plus, or you are just interested in picking the 2 rupee denomination. So you have picked up already the 2 rupee denomination, and the value, since you want 2 rupees, so you wanted 2 rupees, and right now you have already picked the denomination whose value is 2. So how much amount now you need? 0, because you have already picked one amount, right? So dp of 1 comma 2, the value will be what? 1 comma 2, the value will be 1 1 plus dp of 2 0. 2 0 is nothing but 1. So what will be the answer? 2. This cell is filled with 2. I hope you got the point. Similarly, I want 3 rupees using 2 rupee denominations. Okay, I want 3 rupees using I want 3 rupees, given that I can use the denomination pointed by this index. What is the index pointed by this? 2 minus 1 1 2, means you can use denomination 1 also, denomination 2 also. So suppose in your pocket you have 1 rupee denomination and 2 rupee denomination, 2 rupee coins, and I am interested in getting 3 rupees. In how many ways can you get it? So what will I do? First of all, I will say, okay, what is the maximum denomination? I have 2. So I will assume that I am not using this. Then you can, what will you do? You will say dp of, I have assumed that I am not using this 2 rupee denomination. So dp of I minus 1. which means if I'm asking you about dp of 2 3, so you will point to dp of 1 3 because you're ignoring I minus 1, plus you will refer to dp of what, I is nothing but 1, sorry 2, I is 2, right? And assuming that you have picked this 2 rupee coin, so if you pick this 2 rupee coin, 3 rupees minus 2 rupees is how much, 1, so j value will be then 1. What? So dp of 1 comma 3, this problem we have already solved. Dp of 1 comma 3, the solution is 1 plus dp of 2 comma 1, so dp of 2 comma 1, the solution is 1. What is the answer? 2. So again you have two ways in which you can actually give me 3 rupees, given that you have, basically you can use 2 rupee coin also. So let's see how this answer comes. So see, I will explain you how actually this is the answer. So as I said, if I'm referring to this row, it indicates that I'm actually pointing to 2 minus 1, that is 1 index, this index, s of 2 minus 1, s of 1, and it means that I can use all the denomination from starting to this. So let me use, what are the denominations I can use? 1 as well as 2. What is the amount I need? 3. So I said that there are two ways. I just calculated mathematically that there are two ways. So how many ways do you think there will be? So basically 1 plus 1 plus 1, you can get 3, or another way is 1 plus 2, 3. You see, two ways are there, isn't it? And that is what it is matching. I hope you are getting the intuition. In this particular way, what did I do? I assume that I am not using 2 rupee coin. So except 2 rupee coin, in how many ways you are getting this? And if I am including this 2 rupee coin, I can get another way, 3 rupees. Right? So this is excluding, this is by ignoring 2 rupee denomination. This is by including 2 rupee denomination, right? This is how we are calculating. Right? So let us fill the next row also, again the similar way. So dp, now you are interested in getting 4 rupees, and given that you can use 1 rupee denomination, 2 rupee denominations, because you are pointing to this row, this indicates this index, means from starting to this index you can use all the denominations. So I can use 1 and 2. I want 4 rupee. One option is I will not use 2 rupee coin. So if you don't use 2 rupee coin, which means you are referring to dp of I minus 1 j. So dp, what do I want? I want dp of 2 comma 4, right? This is I, this is j. So dp of I minus 1 means dp of 1 comma 4. What is the value? 1 comma 4 value is 1. Or if I include the coin, if I include this 2 rupee coin, if I take this 2 rupee coin, then I'll basically be in dp of I j minus s of I minus 1. This is what I have to do, this one. So it will be dp of 2, and I want 4 rupee. So in 4 rupee I have already picked 1 2 rupee coin. So you are basically referring to dp of 2 of 2. Now what is the solution to this? The solution to dp of 2 of 2 is nothing but 2. So 2. So 2 and 1 here. The sum will be 3. So there is 3 ways in which you can get rupees 4, given you have 1 rupee coin as well as 2 rupee coin. How? So given you have a 1 rupee coin and a 2 rupee coin, I am going in very extremely detail. I hope you are not getting bored. This is just for your convenience that I am explaining in detail. So I am pointing to this row again, which indicates I am actually referring to this index. Referring to this index indicates I am including all the denominations from starting till this point. Means you can have 1 denomination as well as 2 rupee denominations. I am interested in getting rupees 4. I calculated that there are 3 ways. Now what are the 3 ways? 1 plus 1 plus 1 plus 1, or 1 plus 1 plus 2, or 1 or 2 plus 2, right? You can see these are the 3 ways in which you can get rupees 4, and exactly it is matching with our answer. So you can see how the sub problems are actually helping us to get the answer, right? Again here, if I have now see, I is pointing to this index, it indicates 3. I is equal to 3 means point to 3 minus 1 is equal to 2, this index, which means now you can use a denomination of 3 also starting from the beginning. So which means I have in my bag 1 rupee coin, 2 rupee coin, 3 rupee coin, and now I am interested in finding 1 rupee. So if you have all these 3 denominations and I am asking you to get 1 rupee, so what will you do? You know that the denomination that you have is rupees 3 maximum, and you cannot get 1 rupee using 3 rupee coin, right? So what was the condition for that? The condition for what, that whenever you come across the condition where s of I minus 1 is greater than the value of j, that is what I am going to write here. If s of I minus 1, that is the maximum allowable denomination, is actually greater than the value j, the amount that you want, then dp of ij will be what? It will be equal to dp of, assume that you are excluding the denomination, because since you cannot get 1 rupee using 3 rupee, I'll assume that I don't have this denomination. So if you don't have this denomination, which means you are referring to the previous row, means this row. What is the previous row? So for that I am saying dp of I minus 1, just ignoring that denomination, and the same value you will be saying how can I do in the previous row. So if I am saying dp of 1 comma 1, so this was 3 comma 1, sorry, this is actually 3 comma 1, right, this cell 3 comma 1. Now you know that this value is actually greater than the value that I want. What will you do? You will say dp of 2 comma 1, refer to dp of 2 comma 1. What is the value of dp of 2 comma 1, which is nothing but 1, so that will be copied here. Same case here, you can use denominations 1 2 3. Okay, you can use denominations 1 2 and 3 because you are pointing to this row, and you want 2 rupees. So I want 2 rupees. So do you think I can use 3 rupee to get 2 rupee? No. So I'll ignore these denominations. Ignoring this denomination, which means now what is the value I want? I want the value of 3 comma 2. So you want the value of dp of 3 comma 2, but you know that this condition appeared wherein the denomination value was greater than the value I want. So I was doing what? dp of I minus 1. So it is equal to dp of 2 and j is nothing but again 2. So dp of 2 what is the value? 2 of 2, value is 2, so 2 will be copied here. Got the point? Similarly for this particular case, I can use which denominations? 1 2 3. I can use the denominations, sorry this is dpij. So I can use the denominations 1 2 3 because my I pointer is now pointing to this row. Pointing to this row means pointing to this index. Pointing to this index means you can use all the denominations from starting to that index. So 1 2 3, all the denominations I can use. I need rupees 3. How many ways can I do? 2 ways. First way is either I will include 3 or I will exclude 3. Suppose you are not considering this 3. So you know that if you are ignoring these denominations, you are actually referring to the previous row. So I want dp of 3 comma 3. So one way is by saying ignore the denomination. So dp of 2 comma 3, what is the value? So dp of 2 comma 3, the value will be 2 comma 3, the value will be 2 plus, or if you include this denomination, if you include 3 rupee coin, then you will be left with what? I, that is 3, and j minus s of I minus 1. S of I minus 1 value right now will be how much? 3. 3 minus 3, because j is 3, which is equal to dp of 3 and 0. What is the value? 1. So 1. So 2 plus 1 equal to 3. So the value of this cell will be 3. Got the point? Means there are 3 ways in which you can get rupees 3 using, given that you have these 3 denominations, right? Anyway, now finally we are coming to this problem. What is the problem? The problem is you are in which row? So let me erase this again. Okay, so you are in the last row definitely, right? You are in the last row. And what do I want? I want dp of 3 of 4. So right. So what is the thing that I can do? Which means you can use denomination 1, 2 and 3. So 2 possibilities. Either I will include 3 or exclude 3. So for that only I should write the condition here. For those things only, right? For those cases I have already been using here right now. Else dp of ij is equal to what? dp of I minus 1. Sorry. Square bracket. dp of I minus 1 and j plus, which means I am excluding the denomination, maximum denomination, or if you are including the denomination, that it will be I comma, so I and j minus capital S of I minus 1. I hope you are understanding why I am doing so. Got the point? I am doing plus. Why? Because this is one possible way, plus this is another possible way. So I just have to count total ways. That is why I am adding both the ways. This way also plus this way also. Getting the point? So if I talk about dp 3 comma 4, 1 2 3, one possible way is ignoring these denominations. If you ignore this denomination means you are referring to the previous row, because if you point to the previous row only, then the maximum allowable denominations will be 1 and 2, right? So the solution will be dp of I minus 1, that is 2 4 plus dp of 3, and assuming that you have picked up the maximum denominations. Maximum denomination here is 3. Assuming you have picked up 3 and you want 4, so 4 minus 3 will be how much? 1. 4 means j, s of I minus 1 is 3, so 1. So what is the value of 2 comma 4? The value of 2 comma 4, this problem has already been solved, is 3, plus value of 3 comma 1 is nothing but 1. The answer to this is 4. So where is the answer stored? Our answer is stored in the last cell. Hence, after doing all these operations, we should basically return what? dp of m comma n. This is what we want. One more thing, since we are dealing with integer long int, so basically we should declare all the variables as long, right? So I have not declared any variables here, so I should declare. So long int what m is already declared, so don't worry about it. So yeah, so I should actually declare long type, this array long, right? And I'm using I and j, so let it be integer I comma j only. Yeah, things are fine now, and I'll be returning the last cell value. So that's it. Let us see the code works fine. I hope you got the intuition. That's why I'm saying this problems are very fundamental and classical. Okay, this is small s, I should write it as capital S, right? So this should be capital S. So these are very classical and fundamental problems. It's very important that you actually go through these problems, right? You should actually go through this particular solution and refer to both the problems that I have discussed, the minimum coins also and this coin change problem also. Both problems are equally important. I think we are just encountering few issues. Okay, this should be inside the bracket, I'm sorry. Yeah, right. So this was all about the coin change problem. I hope this video was helpful, right? So in case of any doubt, you can feel free to put it out in the comment section. We are having a little segmentation error. Let us see where is the error actually. So I am actually referring to dp of m comma n, and I think it is fine. So what is the issue? Let us see. So let me just clear this part. So there was little segmentation fault type. Let me see what is the error. So we have dealt with this condition, we have dealt with this condition, we have also dealt with this condition. Okay, fine. And what we are doing is finally returning also. Okay, I'm really sorry for that. So we have not used the for loop now, see, because I was just giving you the pseudocode, right? So while writing the pseudocode, I just forgot to write the main code. So I is equal to 0, I less than equal to n, I plus plus, right? And for j is equal to 0, j less than equal to n, j plus plus. So this will be basically m, because m is in the row and n is in the columns, and inside it you are basically going to write this entire code that we have written, right? So this entire code is going to be written inside it, because it will be looped. And finally, once the loop terminates, then you can basically come out of the loop and return the value, right? So this is the function returning the value here. It's fine. This should work fine now. So yes, it is working fine. We got the output as 4. Let us submit the code. And yes, the problem has worked fine. So I hope this video was helpful. In case of any doubt, please feel free to put it out in the comment section. Just like, share and subscribe. Yes, the video has gone a bit lengthy because I'm just trying to explain you as simple as possible, right? I don't want to leave any stones unturned. Anyway, it doesn't matter. So it was worth 43 minutes, and I hope it was helpful for you. So please like, share and subscribe. Thank you.